Hello everyone, welcome to week 6. In this week, we are going to implement a logical database design. So, before we move ahead with the logical database design, we need to understand what exactly logical database design consists of. So, in week 1, we have said that whenever we are processing or start creating our databases, we have to go through three stages. The first stage or step was conception and database design, which was creating ERD diagrams based on user requirement. The second step we had was related to a logical database design, where we'll be taking that ERD diagram and start implementing using database management system or SQL language, which is structured query language. So this is our learning outcomes or learning objectives, which means that we are going through the activities or steps of logical database design. So what is logical database design? So logical database design means that we will take a conception design, we'll make sure that we take that design and start constructing our database using structured query language. We have to decide what type of database management system we'll be using, whether we are using relation database management system or we are using no SQL database management system, such as MongoDB. But in this course, we are focusing mainly on MySQL. But there are a number of different type of relation database management system. We call it as RDMS are available, such as SQL Server, Oracle, or Access, and so on. In order to create a logical design, we have to make sure that we go through these four steps. We'll look at these ones in more in detail. The first step we have to map the conceptual model to our logical model, which means that we have to look at the first step we have to look at the entities and try to find what type of degree of relationship we have. Okay, so we have to look at the degree of relationships, which means we have to find that whether we have a binary relationship, which means we have a relationship between two entities, let's say entity one and entity two. Okay, or we have a relationship between a ternary. Ternary means that we have a relationship between we have third entity or here it can be junction table. We call it as ternary. Conceptual. This is our junction table or intersection table, or we can have a link with our junction table as well, which will become our fourth entity. It can be also ternary, and we have call it as logical relation to degrees. Once we have identified, we have to decide that where exactly we have to place our foreign keys. For that, we have to find which entity is strong entity and which one is our weak entity. For strong entity, we says that it can exist without another entity, or we can say that it is independent entity. Whereas, which means it is not depending on any other entity. Weak entity means it is a dependent entity, which means it cannot exist without other entity. Okay. So we always place a foreign key in weak entity. We do have a supertype and subtype, which is an inheritance generalization concept. So if we have one entity which can have subcategories, we will look at that how we can categorize, how we can create a subtypes as well. Okay. In that subtype, we have to make sure we are linking them through the primary keys and the foreign keys. So this is a simple concept. So this is a simple college conception diagram which consists of course, class, and professors and employers. So each one have a link between them. So we know that one course can have multiple classes. We may have same course which is taken in different sets. For example, in BCIT we have set A, set B, and set C who are taking the same courses but in different classes. Then we are saying that one professor can teach one class, one professor can teach in multiple classes, and from employee to professor, we can say that one employee can be only a professor, one professor. But it's not mandatory that he will be a professor, so we have an optional thing. Now, how we can validate our logical model using normalization? First of all, we always have to make sure that we're going through the first normal form, second normal form, and the third normal form, which means we need to identify our third normal. We have to make sure we are removing our partial dependencies, and we are also removing the no val multi values. And also we are making sure there is no transitive dependencies. Also, we have to make sure there are the whatever integrity constraints we had earlier, we are following in our third normal form. So third normal form should be there at least. Also, we have to look at the functional dependencies. We always draw the dependency diagram. This is something we have covered in our week 5 as well. So now we have to validate the logical model integrity constraints, which means we have to go through the integrity constraints such as domain, which means data type and data size. We keep repeating the same concept again and again. So data type and data size. We have entity constraint, which means we need to have a primary key. We have referential, which means we need to have a foreign key here. So foreign key, we also have certain more rules. For example, if we are setting our referential mode, we are following the referential constraints. We have to make sure we are applying any of the constraints. We have number of constraints are there, which is belong to referential constraint, integrity constraint. The first one is null, which means null means that whenever we are applying any changes in our base table, not the table where we have placed our foreign key, if we have updated there, the other table which consists of foreign key will be padded with the null values. So let's say we have a customer here, and here we have invoice. So we are saying that customer ID here is a foreign key and it is a primary key here. So whatever information we update in the customer, it will not, it will update in an invoice in terms of filling it by null values. Okay, this is the first constraint. The second constraint in referential model is up to us whether we want to place it as null, whether we want to apply something called as a cascade, which means if we have changed our CID here, it will reflect here as well. So it will update. Okay, it means it should sync. Update means it should sync together. Now for the third one we have a restrict. Restrict means that we are stopping our second table which consists of a foreign key to update. Restrict means stopping it to update it. So these are the three ones we mostly follow. We do have on action as well or no action also, which doesn't do anything, which is a default one. So we have a no action which doesn't do any actions, and this is a default one. Now, fourth one we have to make sure that we are looking at our logical model and make sure that we have a user requirements and we try to match whether it matches the requirements we have or not. For that, we have to look at the different views. We have a manager view, we have a designer view. So we look at that how this database design you have created are they solving the problem, what is the solution we have provided, are you able to retrieve the information which you want to, are you able to generate the design information or not. So this is for the manager view. For designer view, you are looking at that how well the data is structured. Okay, is it transform or not, whether there's an error, whether there is an anomaly or not. So these are the things we will consider as a designer view. So this is a reference which I have used for this topic. So in case if you want to read further, you can refer to this book. Okay, but this information is more than enough. In case if you want to read further, this is a book you should refer to. Thank you.